How's it going, everyone? Eulier Gonzalez here again, and today it'll be the last video of this async nature in JavaScript and how that works. So we're going to focus is on how can we create now an async and await behavior using the generators and these concepts that provide now the language for us as a way to, by looking at a diagram of the async and await, understand what it's doing behind the scenes, and now put a practice when it comes to actually write code to use the async and await, for example, for sequential async operations or in parallel. So that's what we're gonna do today. So this course is now taught by Will Sentence, the CEO of Codesmith, which is now a software engineering and machine learning residency headquarters in New York and California, where now, as I mentioned before in all previous videos, the goal of this course is to look at how now the asynchronous natures works before EX6, and now what are the features that we can use that make our life much more simple with the ES6 and ES7 features, how that works behind the scenes, how by looking at now this particular way of accessing data through iterators, and how can we have control over our flow of data with generators. We can combine them to make sense and understand what now this async and await syntax from ES7 actually works behind the scenes. So that's quite interesting, okay? And also part of the goal of this series of videos is to improve a couple aspects that are required for any senior role out there, and that is your analytical skills. How is your thinking process, your technical communications? So can I implement your approach based on your explanation? And the other is, following is a good engineering best practice. Develop your soft skills. Hey, you must develop patience for yourself and others. Are you empathic? And lastly, the domain-specific knowledge, in our case, in JavaScript. So just to make a quick recap of all of these concepts, as a way to say, hey, now, this is when we're going to, this is the course structure, as I mentioned. So this, in the introduction, we went over to look at what are the relevant parts that is important to understand is the async nature. As a way to recap is now the fundamental of JavaScript, which is the thread of execution, the variable environment, as well as the variable environment, global variable environment, the function execution context, which contains its own threads of execution and its own variable environment, as well as the call stack, and this nice little bonus features, which is the closure. So then we look at the asynchronous nature, how now that plays out before EX6, before EX6 exactly. So by using is the callback, which is a facade function that now is provided by the host, whether it is the browser or the server. In that, what you're gonna pass is a reference function reference, a callback to be run sometimes in the future, and when that time is over, you're going to receive that functions in the JavaScript world thanks through the callback queue, which is the way of how now it keep track at all of this function that you are passing, that you are deferring, and is the event loop responsible to actually pass down those callbacks to the call stack when the call stack is empty, and they're going to pass that one at a time, one callback from the callback queue. After all, the callback queue is first in, first out, okay? And that's great, because now once we know this mechanism, how that works in the context of the browser, and now when we look at in the context of Node, that it has different phases or different callbacks to actually handle different events. So unlike the browser, where so far we have looked at how can we handle this timers, how can we defer tasks that will be completed sometimes in the future, and the server, we have now the timers, which is responsible for handling is this timers callback. Each one of those phases that I'm going to describe actually has its own callback queue, and the event loop in the case of Node is going to evaluate all of this callback until exhaustions before jump to the next before jumping to the next stage. So what does it mean? That we have several phases or several events that the node is processing, such as timers, such as pending callbacks. So for example, this is the phase when you analyze the TCP connection, okay? And when something went wrong, this is when you receive is the TCP error connections, which is part of the layer 4 in the OC model, this open system interconnections. As a way to, this model guarantee is how can now different computer systems, different computer hardwares and software can exchange data, can talk to each other. So by looking at that, just to recap that, we have 7 phases. We have the application, where now this is when the user interact with the network, okay? Then we have the presentation, where packaging, encryption, and what will be the format of this data is going to be sent. The season is responsible to guarantee is for how long we're going to keep this communications, and which port is going to be send this data. The transport layer that indicate, hey, which protocol am I going to send, am I going to use to send this data? Is it TCP? It is connection based, or it is UDP. I'm going to send that, and whoever is on the line can receive that. And then we got the network layer, which is what'll be the physical path that this data need to take until its destination. And the data link, which tells us what will be the format in which the data will be sent, especially in the in LAN networks or across nearby devices, across 2 devices. What will be the data flow control? They call that as frame. And then we have now the physical, which is now once it receives all of this data from previous layer, it know what to do by sending is now the raw string data. Again, this is just broadly speaking of what's going on, and this is quite important to understand, at least as a high level understanding, because now it will give you much more precision about when you're writing your code, especially with Node, and when you receive this type of errors in the pending callback. The next one is the idle and prepare. As you can see here, no idle, no event loop. That's right. So the idle and prepare, okay. The idle and prepare, okay. Then we look at the poll callback queue or phase that is now calculating how long should block the poll, the input and output, and processing events in the poll queue. So this is when so this is on the poll is when the incoming connections and data and etc., that kind of thing. But again, this phase is responsible to say for how long it should block and poll the input and output. Okay, so whether it's I'm receiving data or I'm reading data or sending data, for how long should I block and poll the input and output here. So this is the poll phase, and then processing the event in the poll queue. And lastly, we got the check, where this is when for such functions like set immediate actually run. And lastly, the close callbacks, where here is when you handle things like socket destroy. Hey, what you want to do when something close abruptly. So for example, socket destroy or the close event when it is emitted. All of these things are important to understand as a way to see that the event loop on Node has specific handles and use cases to do that. Similar to don't block the event loop. Exactly, the event loop. So this is now similar to the event loop on the browser. We're using is a callback queue. And then we look now at an alternative of writing is asynchronous code or deferring this task that will take some time to complete by using is the promise, which is now the ES6 feature that provide the language as a way to handle async operation. Why is that? Because before that we have something called the pyramid of doom, where you have anytime you write code that depend, anytime that you write asynchronous code that depend on other asynchronous code and so on and so forth, you have to now nested that. So the ECMAScript designer would promise say, wouldn't it be better to at least have all of this async operations at one level, all right? By saying promise.then and then changeable or make it tenable, okay? So we can now in there, once you receive is the, so once you're performing a promise and once you get that data, if you need to run another promise, another async task, you can now get the data right after that, but in the same level. So that's the whole point of using is this. So for example here, if we make an example here, let's say cons promise async, promise 1 second, okay, promise 1 second, and this is a new promise object that now contains the resolve and rejected. Okay, this is now an object in JavaScript that when in our case we want us to now when it is resolved, I want you to send is the resolve data here, but as a callback. All right, this as a callback here. Let's send us 42 as value, and after 1 second, okay, after 1 second, this is what I want you to do. Let me define now another promise 2 seconds, okay, that again is going to be another promise, but in this time we're going to resolve that promise after 2 seconds, which is, hey, using the timer for such function, we're saying, hey, I want you to now resolve this with the value with the value that we are receiving here. Okay, I want you to resolve this after 2 seconds, right? And then you say, hey, that's gonna put this, the string is promise 1 second, and then he will say, hey, promise 2 seconds, right? Okay, so now the idea here is that if I need to run is promise that depend on each other, so for example, promise that 1 second, okay, exactly, promise 1. So the idea here, promise 1 sec, okay. So the idea here, in fact, let me actually see. Okay, I thought that because it's this one, and then you got it. Okay, good. So the idea of this is that when I now call my promise.second, okay, that after all the specifications now are providing you this object that will have is the shape of the value, the status, which indicating as pending. All of these are hidden properties of the object, which is pending initially in the state, or unfulfilled, unrejected. And then you got is now an array of unfulfilled and unrejected, which means that this is what you're going to inject. This is the callback that you're going to inject when the promise is resolved or rejected. So on the dot then is when we actually do that. Okay, hey, if this actually resolve, okay, I just want to now is do this. Well, console.log the value here. Console.log the value here. Okay. Promise 1 second dot then value. I want you to now console.log the value, and then return here is the promise 2 seconds. Okay. So once I return this promise, I can now is at one level, which is after you can define as a catch, as a way to handle error if something went wrong. But what you can see is that after that, now I want to, well, get the value of this. So you can say is value, say promise value 1, okay, that's the way to rendering here. Say promise value 2, that's a way to say, well, now in my case I want you to now run is this. So promise value 2, and that's it. So by running this, okay, oh shit. So by running this, the idea is that now you can throw a promise or an async operation that depend on another async operations, and so on and so forth. Argument less. Syntax error missing after less. Must be promise. We are constructing this well, right? So far so good. Oh no, we still have the problem. Come on, man. All right. Okay. Anyway. Okay. So now, and then promise you. That's quite interesting, and this is something that allows you to now, when you need to depend on this, to say, okay, so when I get the data, I want to work with this, and once I get that, now I want to call another async operation. Now, for example, I want to call to another service out there, Stripe, or yeah, let's say it's Stripe, for example, or Netflix. And then, all right, once I get that data, I want you to now console that log. So this is something interesting. You might wonder, can I access this data from another scope? So for example, by saying, hey, by running is this actually be able to pass down? All right. And the answer is that unless you wrap that function that return is the value for that, you can pass that. In other words, promise dot then here as a way to change that. And then you can receive this data, but as long as the promise throw that, okay, so as long as the promise, for example, as in our case, so as long as this promise say, hey, I want you to now receive that data, all right, which is I'm going to now we're going to build this new object, all right. I'm gonna build this new object, and I want to pass is data to that. So by looking at this and ask our beloved friend, so as long as you now on the promise, okay, as long now on the promise, yeah, as long now on the promise that you return, you pass down that data, yes you can. In our case, because we created a new object here, okay, by looking at the function constructor here, because we create this object here, what if we want to pass dynamic data? You might wonder, Okay, you might wonder, well, is that you're going to receive is that so on the resolve, okay, what you're going to now pass is the callback here. You are going to pass, okay, and I love it. I love that I put that I practice. You are not going to pass this data promise one value to that. The following code. Okay, it seems like you're quite bombarded. For real, nigga? Oh my god. Anyway, how can I access to promise value 1 exactly? How can I access the promise value 1 inside the callback? How can I access the promise value 1 inside the you need to pass down that data there. Oh, return that as attainable. Exactly. Interesting. Is 10 return enough? Okay. Is that then? Okay. Oh, it's because it's return a okay. Return value, a new promise immediately, and this new promise is always pending when returning. Okay. So the dot then, since the dot then return it makes sense. So since the dot then return is a promise here, where is our code, bro? I think it is. Exactly. So since our dot then actually is returning a promise, so when this promise is resolved, we say, hey, dot then, I want you to now pass down, because remember, the tenable ability is that you need to return is a promise to another promise to another promise, and so on and so forth. So because now here in the promise 2 that we are receiving is, well, the promise to value here. All right, so when this is actually resolved, then I want you to return, okay, this promise. All right, then I want you to return the promise whose values are like that, which I want you to return this. Then I want you to return a promise with promise 1. with the promise 1, or in this case the promise 2 as it is. There's a way to make it much more readable. You have to, come on, don't be like that. You'll have is not to return is the statement that will return is a promise that will contain is the value 1, okay, followed by the value 2, the promise 2. But you may wonder, is like, hey, but no, I just want is to actually pass down data, you know. I just want to actually pass down that data to that. And then is when you're going to receive now this data as it is. The promise of promise value to 1, promise of 2, and then here's when you can now finally log that data at the end. A very valid question and a very interesting one. They say, hey, return, exactly. This one, you get this. There's no need to do this because we're actually returning this, and then we evaluate that. Or in our case, we can say is something like this. Sending that as a template string, promise value 1, and then promise value 2 as it is, right? So now that we evaluate this with a single moment, all right, come on, man. Okay, you think you're funny? Okay, and there you got it. So now let's go to save this, redeclaration, that's right. And now you are going to be able to access to that data as it is. Promise value 1 and promise value 2. Of course, because that's not the way how it was defined. And you're not gonna give it, you're not gonna actually making a proper reference to that. And here we got it. Okay, so now this will as expected. And then you get now the promise. So this is now the way of how you can actually is tenables or change is promise the other. So you're gonna change this promise after the another. And for example, if you want to reuse some of the previous data that you get from this previous async operations unfulfilled, all right, I want you to now work with this. But to do that, I need you to return that. If that was fulfilled. If it's not, then throw that. So because all of this control is something that, especially when you want to handle large amount of connection, when you want to perform several network operations, this can become problematic. So instead of doing this, okay, we can use this, if you need to, now run in parallel. In other words, it's like run promises in parallel by saying, because at the end of the day, this actually is taking 3 seconds to resolve, right? This actually is taking 3 seconds to resolve. This is for sequential promise. Hey, I want you to dispatch this async operation, get the data. I want you to dispatch another async operations, get the data, preserve the previous state, all right, and then work on that data. So if you need, for example, do concurrent operations, okay, it is better to use the promise that all to do this, and that is it is an iterable, something that we're going to talk about that, which is a promise 1 second and promise 2 seconds. And what it's going to do is that I'm going to wait for all of these promise. I want promise or all, wait for all fulfillments or the first rejected. So this is great, okay? Because now you can see is the value of this collections of values here. So now it's actually triggering all of these promise at once, okay, and wait for all fulfillments or the first rejected. So in our case is as it is, right? We get the data like so. So that's quite convenient here. That is very, very, very convenient. As it is. So in this case, it needs to be actually yes, and this is a promise object here. That's right. You're going to pass this that, okay, and the promise that all, what you're going to do is, yes, exactly, evaluate all of that as it is. Already fulfilled if the iterable pass is empty, okay, and asynchronous fulfilled and asynchronous rejected. So this method is one of the promise concurrency method. It can be useful for aggregating the result of multiple promises. Aggregating the result of multiple promises for data aggregation. And this concept is something fairly important, especially if you're going to now do several async operations, right? It can be useful for aggregating the result of multiple promises. One of the problems of this is that you are now relying is on those promises always will be fulfilled, okay? So this can be useful, for example, if you want to read files, okay, locally, all right? That might be one. That might be good. Or if you are reading is to your local database, but again, for reading operations. Why is that? Because if you do, for example, a post operations or a write operations, and if you want to roll back that operations, what you're gonna do? That's why we need things like transactions, and follow is the ACID principle, which is the atomicity, consistency, atomicity, consistency, atomicity, consistency, isolations, and durability. Why is that? Because now you have to guarantee that that transactions actually was fulfilled as it is, as expected. So that's quite interesting. That's very, very quite interesting here, because again, we can use the promise.all as a way to perform concurring for concurrency, but it'll wait all fulfillments or the first rejections, but it doesn't tell you which one of them fail. Okay, so if you want to have much more fine control over what's going on, okay, now it is a promise method typically when you have multiple async tasks that are not dependent on one another to complete successfully. So this is now more interesting because with promise all settled, okay, with promise all settled, you can have now much more fine control of what went wrong. Okay, and if any one of those promises actually went wrong, okay, now you're going to receive is this format, this standard here. It's like, hey, this is the object. I'm going to provide you the promise object, which is the status and their value. Or if it is rejected, the reason. So now here you can actually have much more fine control of what went wrong. So you can now receive is the index as a way to detect what happened there. So that's quite interesting. That's quite interesting. Promise all settled. And then, okay, now with that huge introduction of the promise and that kind of thing, the ECMAScript is so. And again, all of these things, okay, you may wonder is like how now all of this async operation is working behind the scenes, okay, because you create is an object, you create an object here, okay, and what it's doing here is that by creating is this object in JavaScript, and when you wrap that with a fetch function, this fetch function, or another function to read file that return a promise, for example, read files on node, once you do that here, it's like, all right, so what do I need to do? What do I need to move on? What are the things here that's happening behind the scenes? So when you create this new promise objects, to, in our particular case, pass down a timer to be resolved after 2 seconds, we're making use of the timer fetch function. And that is, it actually is a two-pronged task here. So the promise here is doing two-pronged. One of them is creating the promise objects here and defining the status, initially pending, the value, and unfulfilled, okay, which is what you're doing is on the dot then I want you to now run this unfulfilled. I want you to run this callback here, and on rejected, which is actually is this hidden property on rejected, I want you to now is do this for me, run this callback. So now this is quite interesting because when that time has passed, okay, this promise or this callback, instead of being added to the callback queue, it will be added to the microtask queue, which is another queue that has more priority than the callback. And in the case of the browser, they call that job queue or microtask queue. It's going to do the same as the callback, but with a difference. It's like, if the call stack is empty, let me now grab all of these callback from the microtask queue until exhaustions before moving to the next element on the callback queue, right? And then grab that element from the callback queue, pass to the event loop, pass that to the call stack, and then now evaluate is the micro task queue. Okay, do we have something on the call stack? No? All right, let me evaluate everything that I got here in the micro task until exhaustion. And then it asks again, do we have something in the call stack? No? Now let me get is the last element on the callback queue. In other words, is the queue this in the first position, first in, first out. So let me grab that and pass to the event loop. But I'm gonna get is just only one and repeat the process. So the micro task queue is evaluating is until exhaustion, meaning that you can have an endless evaluation of micro task, which it never reached to the callback queue. So this is something to consider, and is part of the event loop designed using now the micro task queue. So now that we have this mental model of how now the async, now how the asynchronicity with promise works, okay, and now with callbacks, the web APIs, or in the case of Node is some Node APIs. So with callbacks, web API, promise, the event loop, and the micro task queue, now we can defer works to be done in the future while in the background continues evaluating our code. And when that time has passed, we can now evaluate them. This now allows us these powerful JavaScript modern applications that are capable to handle this asynchronous operations, which is something that the JavaScript per se cannot do that. It was not designed for that. It was just designed to be an interpreted language as a way to say, hey, I'm going to evaluate is his line after the another, okay? And it is dynamically typed, and it is dynamic because you can change now the value of the variables in there. And okay. So now that we take a look at how can we use this, so the MScript design in EX7 now provides is a nice little function that what allows us developers is to look at how now this actually works. Okay, this is going to make our async operations to be on one line. So on the next line, we get the data for that. So now we are actually following is the intuitive JavaScript nature when you write your code. And I really love about this async and await syntax. But before that, we need to take a look at how that works by using some of these new features that the language provides us. And that is the iterators, which is all about saying, well, because most of the time we work with collections of data, not with one simple object or one simple state, hash maps and the kind of things. We want is to find a way to anytime we run a function, we get the first element. We run the function again, the next one. If we hit the function again, we get the next one, and so on and so forth. Why this is important? Because once we have now this ability, because accessing to data is a task in itself, so once we have this ability here, we can now decoupling is how we access to our data, so we don't actually dedicate time to that, and we can focus on things that really matter, which is what we're going to do with the data. And I think that this is something compelling. This is something quite compelling, especially if you have to now dealing with all of this business logic and the business logic and the data of that. But before that, we need to know how that works before, okay, as a way to make sense of how do we get here. And now when you learn that, when you understand that, then you will embrace complexity. So before that, we use is the for loop as a way to iterate through a collection of values. So for example, array like that. Even though I actually write it down here in this sentence here, by saying is like, okay, let's see how to iterate through. No. Exactly. Let's see how to iterate without the iterator protocol through several data types, strings, arrays, and objects. And as you can see, we define our data here, Loren Gibson dollar, Loren, and objects. This iterator is a design pattern which it solves a common problem, okay, by it solves a common problem with a typical, it provides a typical solutions to solve a common problem. And the common problem here is that how do you iterate to all of this data structure, data type, whether it's a string or an array or an object, or more complex data structures like linked lists or trees, more object, more graph. So how now we can actually iterate through all of this? And before iterators, each one of them has a particular methods. Following, of course, is the for or the looping syntax. But each one of them has a particular method, a particular way to access to each one of them. All right, and some of that contains a little bit more logic than another. And even though that once you understand this, there is nothing wrong with that. You know this is using is the right tool for the job. Or when you go out to a restaurant, it's like, hey, if you're going to eat some noodles, Chinese noodles, you use these sticks, okay, wooden stick. If you go to eat pasta to an Italian restaurant, you eat a fork or a soup. If you wanna eat, if you're gonna go for a soup, a spoon. So this is quite interesting, okay, because even though that we have now this particular way of doing things, but actually is when we need to actually use with other data structures that might come up later, okay, linked lists, graph, or trees. So how do we know a particular way to actually only cares about how do we only get the data that we want? That's all, because that's particularly that's the software engineer job is mainly. It's like, okay, now that I get the data, what can I do? What do I need to do with? What I need to do with this? Okay, so we got this using the iterator protocol. The idea here is to now increase readability and a standard way to iterate through object as long as they implement the iterator protocol. So you can see this is way much more cleaner, okay? But they need to implement some protocol, some contract behind the scenes. And that is, well, that the iterator, okay, the iterative protocol is made of two parts. It's the iterable, which is, this is now the behavior that I want to define when you want to be consumed by a looping, specifically a for of looping, okay? And now the iterator, which is, this is the standard way of how I'm going to produce this data. So we also actually create is an iterable for us, okay? Yeah, let me remove this. We also create an iterator, user-defined iterator. So for example, when you want to know is the words, you want to know is the words of a sentence, we receive is the string, and here we are making uses now of the way of how you can create objects in JavaScript using is the new keyword dot string, okay? And now I want to make this object be recognized by the for of, okay, or by this looping syntax that accept is the iterator protocol. And first we define is the iterative behavior by saying, hey, under the prototype, which is now a property that has all of the functions, objects, okay, because at the end of the day in JavaScript everything is an object, okay. So function is a special type of object that is callable, okay, and it has now this prototype where this is when you can now, this is the object portion of the function, okay, and also has a reference to the proto, and also have is a proto property, it's a hidden property that now has a reference to access to property and methods from other objects, in this case from the function built-in objects, where now you can have things like call or apply or bind and to string, okay, that inside of that object it also have a reference, okay, under the proto that points that to the objects, which means that you can have access to the object properties like get on properties, or you can have access to the method of the object like get on properties, create object.create, and that kind of thing. So this is the way of how now subclassing actually works behind the scenes. Again, might be quite beyond the scope of this topic. As a way, it's important to recap. If you want to know more about this, we're going to talk that in another video on the object-oriented programming in JavaScript. So the idea here is by indicating now is, hey, this function or this object here is going to make use of the iterator protocol, okay, which is, now you define is a function here by saying, all right, what will be is the behavior of this, what will be the iterative behavior that anytime a looping who knows the iterator protocol needs to do, okay. And here is when, well, we define is this particular strategy here, which is, hey, let me now is split all the words here by accessing to the string, and by say split all of this, I think it is, no, I think it's this, split all of this by white space, which is a special character here of the regular expression, okay. And then we say, all right, the way of now this function must return, or the shape of this object is returning is the iterator protocol, which is an object that it needs a function called next, and that function next must return is an object of the value that contains the current value as well as the done, as a way to indicate, hey, are we done iterating this iterable, right? Is this collection? Yes. All right. And that's exactly what we did here by defining is using the next. Okay, but here doing that as an arrow function. Okay, as a way to now enclose or provide is a closure here, which where now we can have access to the value of the string. Okay, that's why we can actually access to the value of string, or instead of doing that, we just define is that for us as words. But we need is an index here. We need an index here, and also we need is the ability to increment that, this iterative behavior. So by doing here is the word index as it is, where now initially it will have is the value, okay, and then we say, all right, so if the index is less than the words dot length, okay, if it is, then I want you to now is, well, increment the index here, and then return is this object standard following is the operator, the iterator protocol that has is the value followed by the next here, followed by the done, where initially or any as long as we haven't end this is done, otherwise then return is the shape of the value with the done as true. Okay, so now by defining is that iterated logic that I really hate that actually this work has like that. And I really hate that you do that to me like that. No problem. Okay, now when we use is the now when we make use of the words objects here, okay, now we can is actually consumed by the for of, and here we're gonna see is it's a now index and value assignment to const index. Oh, of course, because that must be is like so. All right, yeah, you're right, exactly, because now that must be is all right. Yep. Yeah, because that must be is a const, and as you can see here, it's actually iterating through all of these elements by separating them per space. Okay, so that's great, because now with this particular exercise that we did here as a way to say, all right, on that now we have is this particular approach of how can we now access two data one after the another has streams of data. Okay, and when we run the next function, we will add now is able to get that one by one. Okay, so another thing is that on the words, which is something that we already defined, we say, okay, words dot next, okay, because exactly it's only through iterator objects that can consume that. We did here by saying, hey, this is the iterator object that can consume each one of them. So because now we look at how can we access to our data as a stream of flow, we also need a way to actually generate those data as a stream or as a sequence of data. So because now maintaining is the inner state in an iterator requires a careful programming, you will need is to, what we can use is this nice convenient feature of JavaScript called generators. That is a special type of iterators that allow us is to define the iterative or allows us to define an iterative behavior by writing a function whose execution is not continuous. What does it mean is that you can now create is a generator here, say gen object here, okay, and using is a special syntax like function, say, all right, I want now you to is anytime we get into this function, we call the next function we follow is the iterator protocol. I want you to generate, I want you to yield a result for me. So you get is the yield that is say, hey, the first time you call me, I'm going to yield 5, the next time 7, and the next time 6, next time 6, next time 7, and when you call me again, I will not return you this. In fact, I'm going to end the execution of this function. So because here initially we need is to actually run this function, it will not start immediately the function execution context. In fact, it's going to return us an object, and a special type of object, special type of iterator objects, where now we can is iterate through that as a way to say, hey, get into the function and give me that, yield that output, and that is this. Do that, and I want you to do that again. You know, hey, I want you to give me is the next value, which means get into the function execution context. When you find is the yield prop, the yield keyword, evaluate that expressions and get out of that. Get out of the execution context. All of this inward and backward things, getting here and backing, getting there and get out of here, is something that now we have much more control of our data, of our flow of data in a function, which is something that I didn't think that this was quite possible. You may wonder how generators actually works behind the scenes, and it is by using is the closure to pause the execution of the context, which in fact is not pausing that, it's just actually is storing is in a closure is the execute, the state, the variable environment, as well as the thread of execution, the location of that line. Okay, and anytime you run that next function, it's going to now evaluate that execution context. So you're going to put that on the call stack, evaluate that, all right, and then yield from that, which is get out of there, to remove that and store the state of that. That's quite interesting because now this allows us is to now have the ability to not only access to our data here, but also generate its data, and with this generator functions we can also now is not only allow them to act as a consumer, okay, generator as data producers from the duality here, okay, generator as consumers, because after all, at the end of the day, these generators are functions that can be paused and resummed, which enable a variety of applications. So for example, the type of application that this special type of function allows you to do by pause and resume the execution, okay? So generator as iterator data production. So we have now seen how can we actually, in this particular case, look at generator as data production. Hey, take it, you know, as data production, okay? And we also now look at how can we is another application, which is generator as observers, or in other words, is like generator as data consumption, okay? So by sending value using the .next, okay, we can here is defined as this. So by sending values to this, all right, so evaluate this expression, okay, and then get out of that. And once you call that next and you pass a parameter, it's going to receive the parameter, and we want us to now is store that in the data. So once we look at which value do we have in that generator, okay, data initially, we can say, hey, I want you to now is add that to the data, okay, and then do data, so data 1, data 2, I want you to yield this, all right, data 2, and then just do that as it is. Okay, so this yield keyword here is it's an operator that is used to pause and resume the generator function, okay, which is allow you to now set arguments from that. Once paused a yield expression, the generator code execution remains paused until the generator next method is called again. If an optional value is passed to the generator next method, that value becomes the value returning by the generator current yield operation. The first next call does not have a corresponding suspend yield operation. Exactly. The first next call does not have a corresponding suspension yield because the first next is actually just for starting up. So there is no way to get the argument passed to the first next call. And that's something important to look at this. So the first time, there is no possible way to actually pass that data. But on the second time, we are now be able to do that. So let's get into it. Let's get into it by saying here. So the first next is actually acting as a it's not a function, of course, because it's generator. So the first is actually just to initialize things here. So when I call that generator again, okay, and now we pass some value to that, let me say, hey, I want you to now do this. This is like 11 as a number. So the value that I'm going to pass this time, it'll be 11. Data here is 5. Data 1 will be undefined in this case. That's right. Data 1 will be undefined in this case. Generator.next initially is exactly data is not defined. You're right. Okay, data is not defined because it's data 1. You're right. So initially, the first next is just to evaluate. It's an initializer. Then you got is a generator dot next here, and because we haven't passed any value, it say, hey, I'm evaluating is this. Data 1 is undefined, so you can see, as you can see here, is that it's not actually do anything here. So data 1 is not passing any data to that. It's not a value. So it's returning, is yielding that, not a value. 6 plus undefined is undefined. 6 plus undefined is not a number. It makes a lot of sense. And the problem is that you're going to carry out that over to all of that. You're going to carry out that over all the way in. It's going to carry out that over all the way in. So how can we fix this behavior here? So by initially say, hey, well, this is now the initializer. Okay, so don't do anything for that. Okay, and then now the second time I want you to now evaluate is what I'm passing to that. Okay, I want you to evaluate what I'm passing you to that. So in this case is like that. So first time you're going to return is 5. Next time, which is initializing, next time is going to return is 6. So that value now will be assigned to the data 2, and we will want is to add the 6, all right, to that, and that's quite interesting. That's quite interesting here. That's quite interesting because it's actually not assigning that data. Okay, it's not working as we thought it should work, because the way now we can fix that behavior is by doing something like this. Initially that, and then return is that. So the next time of the evaluation is value 6. Oh, okay. So the initial is that. And then we now run this. So we're to say foo.next. V is not a number. then is yield that. That's quite interesting. That's quite very, very interesting. Because the first time is the initializer. Then if it wants to pass some data here to 6, the first time is initializer. We want is to now pass this 6 to the new num and then add that. And that's exactly what is working. But again, you are defining is now the control of the flow of data here. Okay? You are defining is the control of the flow of data. That's quite interesting. You can pass this now. So here we look at a simple example of how now we, by passing is that, which becomes the new value here, exactly, which becomes the new value. So it just say, hey, I'm going to evaluate and get out of this. Next time, when I receive this value, okay, next time when I receive that value, I'm going to assign that to the new num and evaluate this expression and yield this expression and get out of this. That's quite compelling. That's quite compelling. All right. This is the initializer. And then what it's doing is adding to that. So by looking now how this actually works here, and how now we can have is this inward and outwards of this, we can now make a look at how can we create finally our async and await syntax. So by now defining is a functor, function generator, a functor of create flow, where now we're going to say, hey, the data that we're going to receive, we're going to say is that now I want you to I want you to is fetch, doing this async operation, fetch for me by calling is now the by calling is now this, okay, by calling now is this, and once you get that data as a promise resolve, I want you to yield that initially, okay, I'm going to return is this promise initially, okay, so by the next time I've been called, all right, I want you to now is pass the data here, so you can now log, the data, so we can now have access to the data as it is. So for that, we need is to now, well, first is create this create next element, create next element, okay, comes as a way to now assign this as a generator by saying create flow. We are now returning is this generator object here that contains all of this, that contains that it return us a iterator object which contains a next, that inside of that has is the value and the DOM property, okay, and because once we get that data, all right, in the case of once we run now these iterators the first time, by doing is return next element here. Once we now call the next element here, and we're getting into the create flow function functor, okay, and getting into the generator function and say, hey, I want you to now evaluate this expression, the fetch, and when that is fulfilled, return is a promise, or yield a promise for me, which is now where our data or future data will be, which is now a promise. And so when we call that, since this is a promise, I want you to now pass a callback that calls this function again, call the generator function as a way to pass the proper data and assign that to the data, okay, so we can have access to the data. All right, which is defining is future data.then. Then you get is the future data.then. I want to define is now what I'm gonna do when unfulfilled. Do when promise is do when promise is resolved, okay, which is now this function. Where now I'm going to get is the data, all right, and trigger is the return next element dot next as a way to now pass the data, so now the create flow can have access to the data, and then we get that. So here we are now defining is the logic of how can we now inside of our generator look at our data and then do something about it, you know, and then once that data is done, we can get the data here. So when we run this, future data is not a then function. Return next element dot next. Oh, because of course it's because the way how now the next element is the shape of the next element, which is dot value here. So here we are mimicking the behavior of async and await. Holy f***ing bro. Oh my god, bro. Oh my French toast god, bro. So as you can see here, these generator functions, this generator function here allows us to have access to this data, and from there we can now do something about it. And I think this is something pretty interesting, and I know I'm talking like in a slow motion as a way to now absorb and understand generally how can you actually mimic a async and await by understanding is the generator concept, where you say initially I want you to, in this generator, again, our generator function is actually behaving the same as the async and await. Is that behind the scenes you are creating is a generator that when with the subtle difference of when you use is the await, okay, it'll the async and await, it tells you, hey, I'm going to now yield this and going to wait for this promise to be resolved, okay? And behind the scenes, now I'm going is to run the promise for you, and when that data is resolved, and when we resolve that promise, only the dot, then I'm going now to trigger this generator so you can have is the data behind. So you can have on the next line is the data. Holy moly, bro. God damn it. That's, we are actually here implementing our own Redux saga. We are now implementing our own Redux saga. Holy moly. Suppose we have a UI to fetch some user data from a remote server when a button is clicked. For brevity, we'll show the action trigger here. And then you dispatch this with the payload, right? So the components dispatch a plain object to the store. We'll create saga that watch for all user fetch request actions and trigger an API to call the user data. So by implementing is this function here, all right, initially you're saying, hey, we're implementing is this one. Initially, when you run the next function, you say, hey, I want you to now call this, which is Redux Saga effects. I want you to call this by saying API fetch user, and this is the data. Okay, I want you to call that, and when that is done, the next time I call you to do that, you're gonna put that on user, evaluate this, okay, and returns that. So you define is the fetch user functionality, worker saga. Worker saga will be fired on user fetch request actions, and star fetch user on each dispatch user fetch requested actions. Allow concurring fetch of the user. Star fetch user on each dispatch. Exactly. Start the user fetch. Exactly. Okay, so now you have much more fine control here about which functions are being executed like this. So when you get in here, it's like, hey, first time, or yield this, take every user fetch request, which is our special functions from the Redux saga. Okay, the fetch user. An alternative, you may use take latest for that. Does not allow concurring fetches of the user if user fetch requests get dispatched while a fetch is already pending. That pending fetch is cancelled and only the latest one will be run. Perhaps this is the desired effect that you want. To run our saga, we'll have to connect it to the Redux store using the Redux Saga middleware. Okay. Using the Redux Saga middleware for that store, configure store, when you're going to define is your Redux source, and here is when you're going to define is your Saga middleware. Okay. Then run the Saga. Saga middleware.run my Saga. Render the application. So this is the getting started, and then you got the beginner tutorial here. We're going to create our first saga following the traditionally. We will write our own hello world version of saga. So by creating that, and then you got it. Actions of that, dispatch that. saga.js. They're gonna export that as generators hello saga. So nothing scary, just a normal function except the this. All it does is to bring a greeting message in the console. In order to run our saga, create a saga middleware with a list of saga to run. So far we have only one hello saga. Connect the saga middleware to the Redux store. We will make the change to the main.js. Exactly, connect, create the saga middleware with a list of sagas. Create the saga middleware. Okay. And then connect the saga middleware to the Redux there. So first we import our saga from this .sagas model. Then we create middlewares using the factory functions and making a synchronous call. Exactly, you define this on the main. Render done.render value on increment or decrement or increment async. Okay, you already define all of those property here. On increment async, I want you to do this, and that kind of thing. We are passing is not these actions here. And note that unlike in Redux thunk, our component dispatch a plain object action. Now we will introduce another saga to perform the asynchronous call. Our use cases follow. On each increment async action we want to, but again we are performing is this yield delay 1000 and then yield put type increment. And then anytime we run this, when we call this, watch increment async. Time for some explanation. And then you say yield all, hello saga, and watch increment, making our code testable. It's a generator function. When you run, it returns an iterator object, and the iterator next method returns an object with the following shape. Exactly. Bold and value. The value field contains the yield expression, the result of the expression after the yield is done. Exactly, something they're quite familiar with. Increment async should return a promise that will be resolved after one promise. Exactly, you are implementing is Redux Saga. Applying the Saga pattern here. That's quite interesting. It's like okay.
Okay, so right, like our systems used to be really simple. We used to be able to have like an app or a website that talked to a stateless service, that talked to this giant canonical database source of truth. And so you got transactions, you got serializability and ACID. So, right, serializability is our guarantee that things look like they sort of happen sequentially. Atomicity is this idea that processed in between systems whether or not affect each other persist. We have service-oriented architectures and microservices, and we don't have canonical sources of truth anymore. Often when we are writing applications, we are interacting with maybe some of our own APIs, or we are interacting with someone else's APIs. And using them, and so we actually cannot, and they all have their own backing stores, right? So there is no, like, okay. So right, like our systems used to be really simple. We used to be able to have like an app or a website. I'm gonna go very quickly through it, but you have a prepare phase where you'll have a single coordinator. The coordinator is very special in the system. He's a single point of failure. And he'll propose to all of the resources involved, hey, we're going to go do this thing. And then all the resources get to vote, yes, I want to do this thing, or no, I do not want to do this thing. And the coordinator collects all of the votes. So once the coordinator has received all of the votes, we now enter the commit phase. And if everyone has said yes, then we say go and do the transaction, commit. And so that is how they achieve atomicity, because everyone is committing at the same time. Or if anyone, they sort of make all of this work, is they have their true time API, and they have or T2 can't take an input from T1, and they can't have any.
A Saga is a collection of sub-transactions.
So if you can break your work into sort of normal system, or into these things, then you have the start of a Saga. Each transaction in the Saga has a compensating transaction, and once again, the interleaving and the not being dependent on one another principle holds here as well. And the thing about these compensating transactions is that they're going to semantically undo the transaction that they correspond to. And so the paper actually acknowledges that because we're dividing the work into these pieces, sometimes you can't return the system to the same state. If you execute a transaction and then you have to compensate, successful distributed Saga looks exactly the same, and we still have our log. We still need a log, but now it's not co-located with a database because we don't have a single database. So we have to have a durable and distributed log that lives somewhere. So this might be Kafka or Azure Service Bus or like whatever you want to use. It just needs to function as a log. You still need a Saga execution coordinator. This is once again a process, and it doesn't live co-located with anything. It's not special. I want to point out that this thing is not special. It is not like our coordinator in two-phase commit. It can die. It has no state. It doesn't do anything special. All of our source of truth is still in that log. So the Saga execution coordinator is this process. It'll first start by committing a message to the log that says, I'm going to do the first request in the Saga, and that has to commit successfully before it can do anything else. It's then going to send a request to the service responsible for handling that, and then once that responds, it will commit that I finished at the same fate. And then if you're in an aborted state, request because we haven't put any additional constraints on them. If in your system you can also like they get really, really upset when you screw them up. And it's always the best game they've ever had, always. So I wrote the majority of this service. And so we have very, very detailed analytics on what you're doing sort of at all times in the game. And so we do this by getting a giant blob of data uploaded to us at the end of every game, and sometimes while you're playing. And so one of the problems that we ran into this system was that people care a lot about these statistics. Like they get really, really upset when you screw them up. And it's always the best game they've ever had, always, shockingly. I mean, like, because like, right, e-gaming is a thing. People play like Halo for money and competition and prize money, and then people like to shit talk with their friends. So, and then they also like we have this whole website that you can go and like deep dive through, and this is just like a fraction of what we have per player. So, some things to know about the statistics service is that you could have 1 to 32 players per game. All of our player data when we did this migration to fully cloud and storage as a service was on Azure Table, which is a key value store. And each player in the key value store had their own actors or grains from Orleans. And so what happens is the Xbox will send us a bunch of statistics. The game actor or like process, you can think of it like that.
I get it why it's so important is to look then at the system designs, bro. To look at the system designs, bro. Oh my God. Yeah, it is. To look at the system designs. I get it. I get it. Original paper and Saga on Saga from MVN. A Saga on Sagas. Patterns and practice. In discussion of CQRS. Message in CQRS. Order aggregate, reservation aggregate, and that kind of thing. Payment aggregate. Placeholders, and it's because Exactly. It's because they have all of these transactions that's going to pass, set reservables, and then made a payment. Once they receive, is like order confirms, order confirms. It's all of this message. That's what happened here. It's all of this exchange of messages and how you need to have control about that. Order process manager, order aggregator, order process manager. Payment aggregator, make reservations, seat reserve, order confirms, and that kind of thing. And the order process manager, as a way to say, hey, what is the first thing that I need to do? This, exactly. And then I need to talk to this, and then I need to talk is to this. Waitlist aggregate, order aggregate, reservation aggregate, waitlist aggregate, payment aggregate. When should I use a process manager? When should I not use a process manager? If your bound context contains a small number of aggregate type. Exactly, as a coordinator here, order process manager. Order aggregate, reservation aggregate, waitlist aggregate, and payment aggregate. And then order confirm. Okay. Okay, saga on sagas. Again, because now you are talking is to, this is CQRS journey. Because now version or system, because now you are talking reference 1, communicating between bound and context. Reference communicating between bound and context, the anti-corruption law, integration with legacy system. That's interesting, saga on sagas. But it's because as a way to now have a coordinator here. It's not gonna handle any business logic, not at all. It's going to handle is now channel composition. It's gonna handle is a it's gonna handle is now. Okay, it makes sense. It's gonna handle here is the order management, order process manager. It makes a lot of sense. Order process management. When your bound context is a large number of events and commands that will be difficult to manage as a collection point-to-point interactions between aggregates. When you want to make it easy to modify message routing in the bound context, exactly. A process manager gives you a simple place where the routing is defined. When you want to modify a message routing, and they call, okay, that's quite interesting. And now we are actually facing is this kind of problems. We are actually facing is this kind of problems, my friend. Okay, that makes a lot of sense. That's quite interesting, by the way. Totally, yeah. Oh my God, yeah. This is the way of how you can create is an async await from the scratch. So instead of us to create that, okay. So instead of us create that, would it be better to actually now let the async and await do that for us. Okay, okay, you got my ears.
Async await simplifies this entire process. Async await.
Give me a second here. continue the execution of that function. Oh my god, that's quite fucked up. Alright.
I would say finally fixes the inversion control problem of callbacks. Actually, this does as well. Async await, we're not going to need to have a function here that triggers the return back into the generator function's execution context. The create flow execution. We're not going to need that anymore. Instead, what's going to be triggered from here is just come straight back in here with the return value. No more triggering of that happening via another function. We're going to walk through it line by line, and this is our final code. We're running slightly long. This is our very, very final code of all of hard parts, all of the beauty of asynchronicity. By the way, though, can we just appreciate for a second, or appreciate yourselves for a second, you've incorporated into your mental model every hard part of the JavaScript engine here. Triggers
so far
back into the generator function's execution context. Async await simplifies this entire process.
So async, exactly. So async await simplify the entire process. That entire process defined in the async generator. In the async generator. Here we're evaluating is the create flow function as a by now us defining that function here. What we're gonna say is I want you to now run, I want you to fetch this data from the from, let me see, it's actually get that exactly. I want you to fetch now this data, public data here. I want you to fetch now this data here, okay, and await, which is a special keyword on the async here. Okay, await is used to, so await is used to wait for a promise and get fulfillment values. Okay, a promise and attainable objects. Okay, an attainable object as well. All right. So await now is doing is this. It's like a wait operator is used to wait for a promise until it is and get its fulfillment values here, which is exactly what we're doing here, and get its fulfillment value, and get its fulfillment value here. And get its fulfillment value here, and attach that to data. Okay, so we can now have access to that. So now we can have access to the data, and by running is now the create flow for that. So there's an interesting question here, because you might wonder, all right, if that is what it is, you know, with this, me first and that's right. Again, that's actually works because you can use the async functions at the top level, okay, top level execution, at a model level, like this. The async function here, it works, okay. Async function execution order, something that we looked at that yesterday. Okay, rewriting a promise chain with an async function like this. All right, and these async functions, okay, you can define as an async function. The main difference between the async function expression and the async function declaration is a function name, which can be omitted. In an async functions expressions, to create anonymous function. An async function expression can be used as an immediately invoked function expression. So you can wrap that async function here and immediately evaluate that, okay, which run as soon as it is defined, allowing you to mimic top level await, which is exactly the reason why allow us to use this JavaScript models. So for example, instead of actually us defining like this, we can now is wrap this async function here, an arrow function, anonymous function, with this particular logic here, like me first, and then say const data the await fetch, okay, which means that I want you to now fetch this data from this API endpoint resource, and I want you to await, and I want you to await for the promise and get its fulfillment value, so we can now have access to the data here. But I want you to now immediately invoke, or I want you to now evaluate this function immediately and run it. That's how you tell to JavaScript this. Immediately evaluate this statement here and run it. And that's what it is. So you can now, it's mimicking is the behavior as an immediately invoke function expression. Okay. You async as an immediately invoke function expression. Okay. So when you're using that here, exactly, hey, I want you to now immediately invoke this here. Exactly. As immediately invoke function expression, which mimic the top level await, which mimics the top level await. Which mimic the top level await here. Mm-hmm. Mm-hmm. Immediately invoke function expression like this. No, okay. Let's get into it. Let's get into it.
Async await. I would say finally fixes the inversion control problem with callbacks. Actually, this does as well. Async await, we're not going to need to have a function here that triggers the return back into the generator function's execution context. The create flow execution. We're not going to need that anymore. Instead, what's going to be triggered from here is just come straight back in here with the return value. No more triggering of that happening via another function. We're going to walk through it line by line, and this is our final code. We're running slightly long. This is our very, very final code of all of hard parts, all of the beauty of asynchronicity. By the way, though, can we just appreciate for a second, or appreciate yourselves for a second, you've incorporated into your mental model every hard part of the JavaScript engine here. The entire web browser features part, the microtask queue, that only person who talks about microtask queue really is a guy called Jake Archibald, truly gifted. I highly recommend him. Brilliant.
Before we jump into that, I will like to recognize the amount
every hard part of the appreciate yourselves for a second.
Exactly. I would like to recognize the yeah, before jumping to that, I would like to recognize exactly. I would like to recognize what you have no,
Of all of hard parts, all of the beauty of asynchronicity. By the way, though, can we just appreciate for a second, or appreciate yourselves for a second?
exactly. Before jumping to that, I would like to recognize, or I would like you to appreciate. I would like you to appreciate what you have done. So before jumping to that, I would like you to appreciate what I would like you to appreciate yourself what we have covered so far.
You've incorporated into your mental model every hard part.
You have incorporated into your mental model every hard part until EX7. It's important because as the language will evolve.
Part of the JavaScript engine here. The entire web browser features part, the microtask queue, that only person who talks about microtask queue really is a guy called Jake Archibald, truly gifted. I highly recommend him. Brilliant British speaker who's a developer evangelist at Google, truly gifted explainer of concepts and sharer of entertaining, humble anecdotes, as is the wont of my people. And he talks about the microtask queue, the only person who does. That's how advanced this stuff is. And you combined all that with a feature of JavaScript in ES7 that only just got released. Generated an async await. And you built async await from scratch. This is async await built If you get a senior dev interview question, which is going to come up more and more, I think, can you build for me async await from scratch?
Mm-hmm. Now you're going. Now you are going to see in Now you're going to see in exactly. So now you're going to see in interview or technical interview, in coding interview, can you implement is a async and await from the scratch. From the scratch. Or from scratch. Exactly. So now you're going to see in coding interview that so show me how can you implement async and away from scratch. Okay.
We just built async await from scratch. Even better, we just built Redux Saga from scratch. Let's try and inflate our achievements even more.
we have basically, when she mentioned that, basically build a Redux Saga. Mm-hmm. Let's go even further. Let's go even further there. Let's go inflate our achievement even further. We have implement a JavaScript engine from scratch. Let's go inflate our achievements even more.
We just built the JavaScript engine from scratch. Even better, we just built Redux Saga from scratch. Let's try and inflate our achievements even more.
Let's try inflate our achievement even more. Even more. Exactly. Let's try to inflate our achievement even more.
We just built the JavaScript engine from scratch. There we go. I feel particularly proud. We just did it. We just built async away from scratch.
Just built Redux Saga, basically.
Even better, we just built Redux Saga from scratch. Let's try and inflate our achievements even more. We just built the JavaScript engine from scratch. There we go. I feel particularly proud of all of you. All right, so we're going to do this though. Final code is going to be doing for us execution context after we've left it. We're able to do so using our return next element.next method that guides us back into the create flow execution context. We manually do so using our next method call, which was triggered by the triggering of our do when data received callback that was attached to our future data promise object. But this flow inwards and outwards, and it gets complex. And so JavaScript gives us a async function that's going to automate that process of going back into the create flow function.
Mm-hmm.
Guides us back into the create flow. Do so using our to return back us. All right, for the first time, my beautiful people, for the first time, we are able to return back into a function's execution context after we've left it.
So for the first time, we are now being able to get out of an execution context and then back into that. And then back into them. Yeah. And I think this is something, this is a pattern that seems quite interesting, or seems quite wild to generate, to do that. We didn't think that actually can be possible. Okay. But for the first time, now we have the ability to get out of the execution context and back into them. That's something interesting, because most of the time when we run a function, we just run it, say brand new execution context, we evaluate all of that, and then we return that. But now, for the first time, we have now the ability to get out of an execution context and come back to them. Okay. Mm-hmm.
We're able to do so using our return next element dot next method.
So we are doing so. Okay, so we are doing so by running our next method to get into that.
That guides us back into the create flow.
Mm-hmm. That guide us back into the create flow function or generator here. Take a look at the yeah. Take a look at the code below. Okay, that will guide us through. That will guide us through. That will guide us back in the create flow. In deal.
Execution context. We manually do so using our next method call, which was triggered by the
So we exactly. So we okay. So the first thing now is that we are able to get an execution context and back into them. So by running is the next method, it guides us through into the generator context, the create flow. Okay, and so we made it manually by running the next method. Okay, that when it's run,
triggering of our do when data received callback, that was a next method call, which was triggered by the triggering of our do when data received callback, that was attached to our future data promise of. By the triggering of our do when data received.
So we manually is running. So we manually by running exactly, because this is the storytelling here. So first thing first, now we have the ability, for the first time we have now the ability to get into, yeah, we have now, so for the first time we have now the ability to get out of an execution context and get back to that. So by running is the next method, it allows us to get into the create flow, into the generator function execution context, Okay, and then we manually, which is something we manually do that, and the result, and then when that promise is resolved, okay, and when that promise is resolved, which means that is the browser, which means that the browser now finally is give us the result, update the promise object value here. So then when the promise is resolved, we attach a callback, the do when data is data receive, okay, to trigger us back into the create flow with our data, so we can now access to that.
Callback that was attached to our future data promise object. But this flow, inwards and outwards, gets complex. And
so, but this flow, inward and outward, inward and outward, get complex. Get complex. So now the async and await
gives us a async function that's going to automate that process of going back into the create flow function.
So now, exactly, so now JavaScript will give us, yeah, so now JavaScript will give us is a convenient, a compelling feature, async and await, that automate that process for us. And that's quite interesting.
Don't worry, we don't have to trigger going back into it. Instead, we're going to go automatically back into it. We're going to pass the response object value back in as the evaluated result of the yield expression, and store that straight in data. It's going to simplify.
So we're going to parse that up. So we're going to parse is that fetch object yield, and when we get that data available, we're going to pin that to we're going to make that available to the data that we want to make use.
Code for us with the help of the new async functions. Async await simplifies all of this and finally cleans up our inversion of control problem of callbacks. We're going to see that now, for the first time, we don't define a task to be done beyond our control much later on. Instead, we're going to go into create flow, set up some work, set up a task that takes a long time. That is our speaking to the web browser.
Exactly. So async await automate. So async await simplify that process, keyword there. So async await simplified that process.
That speaks to the internet, gets that tweet, 200 milliseconds brings it back, and then create flow, set up some work, set up a task that takes a long time. That is a task to be done, version of control problem, help of the new async functions. Async await simplifies all of this and finally cleans up our inversion of control.
So async and await simplify that process and solve the inversions of control. Exactly, because at the end of the day we want us to now make our code to look like synchronous to follow is how now JavaScript is, after all, writing and evaluating one line after the another.
Problem of callbacks. We're going to see that now, for the first time, we don't.
So async and await simplify the process and solve the inversion of control of using callbacks.
Define a task to be done beyond our control much later on. Instead, we're going to go into create flow, set up some work, set up a task that takes a long time. That is our speaking to.
So here we are defining a task that will take long time to complete. Okay, so here we're defining a task that will take long time to complete here, and when that is resolved, we can get the data.
The web browser that speaks to the internet gets our tweet, 200 milliseconds brings it back, and then we're going to somehow get back into create flow to continue running our code.
Exactly. And we when that is resolved, we somehow get back into the async function, into the create flow, the async function, to evaluate is the next line.
Sequentially. No need for a triggered function on the promise resolution. Instead, we auto-trigger the resumption of the create flow execution. That functionality is still added to the micro task queue, though. All right, so here we go.
Exactly. So that functionality is still added to the micro task queue. Of course.
So, blessing, line 1, what are we doing?
Async function called create flow.
Excellent. Create flow is defined. It is a function. It is a brand new type of function, a synchronous function. Good. Line 2, blessing.
Function we just created.
Excellent. We're going to invoke create flow, and we are going to immediately enter its execution context. Immediately enter its execution context. There it is. And what is the first thing, blessing, that it tells us to do in this execution context? Let's say at about 1 millisecond.
To console.log me first.
Excellent. So at about 1 millisecond, we hit our console log me first. So we do go into the this isn't like our generator function we have to trigger going into using the next method that the call to the generator function returned out, the next method on that object. Instead, we're going to go into it directly ourselves, just by calling it. So the first thing we do is indeed a console log of the string me first. Perfect. And in our memory, what is the next line of code, blessing, that we are going to encounter?
We declare a constant data.
Perfect, there it is. And for now,
We declare a constant data.
oh, undefined, exactly. So we set data is going to be the evaluated result of that expression on the right-hand side. So there is on the right-hand side, we say await, and then fetch, the return of our wonderful, our final call to our fetch facade function, a two-pronged function that in JavaScript returns out a what, blessing?
Yeah, a promise object.
A promise object, but it also spins up a bunch of work in the web browser.
First, we are evaluating the following diagram. Exactly. The following diagram show is the hell. Okay. The following diagram shows the following diagram shows memory. Exactly. Async create flow async function or definition. Okay. Definition of async function create flow in memory. Okay, and then run create flow and evaluate is the console log, and evaluate is console log, and await fetch for that, and await fetch. Which return is a promise object. Oh my god. And we're back. Good. Awesome. Awesome. Exactly. Await fetch, which return with a fetch. Exactly, fetch, which return is a promise object when resolved. Exactly, which return is a promise object. A promise object with a resolve object, with a resolve response object. Okay.
Itself. So let's do the JavaScript piece first. We are going to return out a promise object, just like I said, with two. We have a few properties, but two important properties: value and on fulfillment, which is an empty array. Both right now, nothing interesting in them yet. The value is going to be auto-filled in with whatever comes back from the web browser, features, background work, and the on-fulfillment array, well, we'll see what that's going to do here. Good. But, oh, and that object here. We're going to hold it here for now. But in the web browser, what background feature /1, something like whatever it is, and the type of request we're making, and it's a GET request. And we are sending off an HTTP.
The XHR use an extender. It is interesting. Why?
That's the H in the XHR. HTTP message off to Twitter. It's at 1 minute 8. It's just a position in memory. So we know that we're referring to this object we defined. The browser knows where that object is stored, and that's the value property is going to update. Okay, perfect. Good. And now the all-powerful await is going to throw us out of the create flow execution context. I have a very clean eye. We're going to throw it out.
So now when the data is so now when the promise is resolved, okay, so now when the promise is resolved here, okay, so now when the promise is resolved, the await, the await keyword will kick us from the execution context of our async and await, okay, and perform exactly. Okay. Of our async and await function, which is create flow, all right, and continue evaluate is the next line of our code. Interesting. So the await here, the await, it can be only used inside of an async function or a top level of a model. The description, what is usually to await is usually used to the return value, the fulfillment value of the promise of a attainable object. If the expression is not attainable, the expression's owns value. Okay, the expression's owns value. So if we take a look now at the duality here, duality with async and await. Simplifying asynchronous computation via generators. Natural numbers. Oh, but this is the proposal. It's implemented in a generator, but this is 10 years ago, you know? It's like... Regenerator, which can compile ex5 code containing async and await down to vanilla to run in the existing browsers and runtime. Regenerator. Variant. Duality. Exactly. Duality of async await. Yes, proposal async function. Implementing iterables via generators. Blocking on a synchronous function call. What are generators? This is describing as generators. Oh, we're not into that. I'm more for this. Know your promise. Async function are started synchronously, settled asynchronously. Async function started synchronously, settled asynchronously. Exactly. It's going to demonstrate that how that works. It's actually return ABC. This is synchronous. So when you call async function, this will behave is synchronous. Even though that, okay. Output async function. Really? Really? Interesting. Okay. It starts synchronously, settle asynchronously. Remember that after all, it's a generator for that. It starts synchronously and settle asynchronously. Then you have the async function here. The next line is, hey, this is a .dem. I'm going to evaluate that later on here, and then I'm going to evaluate the console.log here. So first thing first is say, hey, I'm going to run this. I'm gonna get it here, and because the async functions at the end of the day return is a promise. It doesn't tell you here, name parameter, examples, async functions. Async functions. But they start like that. declaration, create an async function object. Okay, an async function object. Which is a subclass of function. Each time when an async function is called, it returns a new promise which will be resolved with the value returned by the async function. Which will be returned by the value. Okay. In other words, if you say something like this, async function, all right, then you say console log here, me first, okay, and then on return you're gonna say is do 2, okay, and then you assign this as it is by saying async function, async, come on, by saying async function. So when I run the async function here, I want to know what is the output of this, which according to the description it is a promise. Exactly, it is a promise. Makes sense. So the return output of this async function is a promise with the return exact. So it returns a promise, and because it returns a promise, it makes a lot of sense. It say, hey, I'm not going to evaluate that synchronously. When I evaluate the return inside of an async and say no, I'm going to now append that to the micro task. Okay, that makes sense. I'm going to evaluate this and say, hey, this async, yeah, I'm gonna first run the async functions. It starts synchronously, and then yeah, async function started synchronously and settled asynchronously. So you run this as it is and say, hey, it starts synchronously. You're going to return this, which is a promise, which means that I'm going to defer that, I'm going to pass that to the micro task queue, that callback that you append that, which is here, to be evaluated later. And then I'm going to now evaluate is not only this, but then I'm going to evaluate is the next line, which is main. And once now I evaluate as JavaScript, now when JavaScript evaluate is all of this synchronous task, all right, it is time to look at, for the event loop, do we have something on the micro task? Yeah, we have a promise that we create here where we subscribe or where we attach this callback that now I want you to evaluate that. Put it on the call stack and evaluate that, which is resolve the return promise here on that, which is ABC. You can rely on the following order. Line A, the async function started synchronously. The async function promise is resolved via return. Line C, execution continues. Okay. Line C, execution continues. And line B, notification of the promise resolution happened asynchronously. But as you can see, you have now this inversion control of thing. Return promise are not wrapped. Resolving a promise is a standard operation. Return used to resolve the promise P of an async function. That means returning a non-promise value fulfills P with that value. Returning a promise means that the P now mirrors the state of that promise. Intriguingly, returning a reject promise leads to the result of an async function being rejected. Normally, you have used throw for that. That is in line with how promise resolution works. It enables you to forward both fulfillment and rejection of another asynchronous computation without an await. So here you can now run this. So this async function's return is a promise for that. So the previous code is roughly similar but more efficient than the following code, which unwraps the promise of another async function, only to wrap it again. Don't forget await. One easy mistake to make is async function is to forget await. When making a synchronous fall like this, missing await. Exactly, because it's evaluating this synchronously. It starts synchronously and settle asynchronously, as long as you define is an await. Know what you want in an async function. Await can even make sense if async function doesn't return anything. Then its promise is simply used as a signal for telling the caller that it is finished, for example. The await in line A guarantee that step 1 is completed. It's completely finished before the reminder of foo is executed. You don't need await if you fire and forget. Exactly, because you're running this synchronously. So don't wait. Wait for files to close. Here we don't care when you individually write and finish. This is how you can now write parallelism here, using the promise.all. And once you get that, you say, alright, makes a lot of sense. Instead of awaiting two promise, and now we are awaiting a promise of an array with 2 elements. No await in callbacks. Remember that await only fetches the innermost async function. That surround it can only be used inside. Okay, awaiting callbacks. Remember that await only affect the innermost async, which means that await is going to affect the innermost async. So that's what you need to define is here. Immediately invoke async functions. You can just mimic this behavior as well. Don't worry about unhandled rejections. JavaScript engines are becoming increasingly good at warning about rejections that are not handled. For example, the following code will often fail silently in the past, but most modern JavaScript engines now reported an unhandled rejection. Which is good. Especially in async. Handle that. So the idea here is that I keep looking at that particular code, okay, and say, hey,
out of our create flow execution context, where we are going to encounter what line next. Blessing.
Console.log me second.
Me second. Exactly. At about, let's say maybe 2 milliseconds. Something like that. About 2 minutes. In other words, the most important thing we wanted to do
and continue evaluating the next line of our code.
Asynchronous work is set up a task that takes a bunch of time. Word of execution context, where we are going to encounter execution context. And now the all-powerful await is going to throw us out of
which is console log me second.
the key second. Do it with stepping out of our function. Wouldn't that be wonderful? Interesting stuff. Thoroughly dead. Property, the trigger, and we can think of in our on-fulfillment array as effectively the flow back on our call stack and come back in. And the await fetch, await was super powerful. It threw us straight out. We never even got to assign anything to data. That's not a bad thing. We're hoping that data is going to be filled in with whatever this right-hand side evaluates to. And what does it evaluate to, Blessing?
Hi.
To the value from the request to the internet that came back with hi. That is what our await expression evaluates to, hi. And we assign it to what label? To data, exactly. And so when we hit our next line in the body of our create flow function, console log data, data is going to be evaluated to hi, and look at that. At about 202 milliseconds, we get to continue running the rest of our code. We get to continue running the rest of our code inside our create flow function. All that work of returning a value, or the response object that we saw before, into the promise object that we stored in future data, that we then triggered a do when data receive function, that then triggered .next,
.next
return next
on
element
the return next
call,
element.
or return next element object next function that triggered us to go back into create flow. All of that automated. The async function definition is going to handle all of that for us. The await still behaves similar to a yield. Still behaves similar to a yield, but we're going.
So the await behaves similar to a yield.
To hold on storing it on the left-hand side until we get something back from this background work. But now when the value comes back, we're just going to go straight back into create flow and store it in data. This is a beautifully cleaned up version of that highly complex setup we had that was nevertheless a very powerful setup, but now we have a cleaned up version. And by the way, this cleaned up version behind the scenes is doing all of this. So if you want to emulate the async await function definition and call, we can do it ourselves with generators. And this is the senior dev interview question of the next few years. This sort of under-the-hood understanding of JavaScript is the foundation of getting a senior developer position, or a mid-level developer position. It's also deeply satisfying. So I run Codesmith, a community of people build week 100 hours to a special challenge code. It's about your background, online part. It's very nice. One cut, we made it through the day with every single person, many of you are, that was genuinely impressed. 0.3 engineers. Not from one engineer to two, shared your internal mental model of the codes of the new spec of JavaScript, ES6 and ES7. We saw the foundations of JavaScript that led us on this journey. Memory, thread, execution context, call stack. We saw that get augmented by a whole new set of pieces of that architecture. The web browser features, the callback queue, the event loop. We then discovered that there's a new built-in asynchronicity feature of JavaScript, our promise objects, whose deferred functionality is not assigned to the callback queue, but to the microtask queue.
Exactly.
Two additional pieces of our model. We then added this whole new way of thinking about how collections of data can be accessed and then have functionality applied to them, known as iterators, that rethink collections of data as instead of being static things we go and get elements from, instead these beautiful flows of data that when I run a function, switch the tap on, I get the next element. Switch it again, get the next element, like a string flows, what element we got in data. Dynamically determine what the next element would be by defining it in a function and setting our yield keywords to return out those elements as we went. And then we realized what that was doing was allowing us to exit and re-enter an execution context. In other words, begin the calling of a function, eat where we, and then return to that function. So very well done, everybody. I was. Absolutely delighted. Next up, execution context, call. It's if you complete the coding challenge, and that's my goal. I want to be part of a community to do it. And as a side, deep learning, 4 weeks, live online, evening, weekend, where you get the chance.
Wait, what the French stuff is this? Oh, holy moly, no.
build neural networks from scratch. It's very nice. Made it through the day. How is the ability to take impressive? And it's a mindset. I go doing when we're diagramming through. You take yourself from one engineer to genuinely two engineers, maybe more, maybe a multiple, because you've now shared your internal mental model of the code. It is now a shared resource between.
All right. Well, that'll be all for this video. So take care. Bye bye.